For the first question, according to the properties of probability distribution function, we got that f infinity equals 1 and f negative infinity equals 0. So we take it into the function, and then we get that the f infinity, which can be transformed to a times 1, that equals 1, so we get a equals 1, and f negative infinity, we can transform it to a times 0, which is 0 at last, so that is we got that a equals 1, so that f could be a probability distribution function. For the second part, we know from the first question that the a equals 1, so fx now equals to this. So the path starts at x equals a. So we drew this plot according to the graphs of exponential minus x and y, 1 minus x exponential minus x, and then we are going to find the density function fx. The fx is a differential of the big fx, which at last we get it's this one. This is a pulse, and also at x equals 1 a. So we get the function like here, and it starts at this point. For the second question, first we have to find that the probability of x2 equals 1, so that we have two conditions, which is when x1 equals 0 at the same time that the x2 equals 1, and when x1 equals 1 and at this time x2 equals 1. So we just sum up these two parts, we get the probability of x2 equals 1. Since we have already got x2 probability of x2 equals 1, we can know that the probability of x2 equals 0 is just 1 minus 0.64. And it's pretty straightforward. For probability of x3 equals 1, it's the same as these two parts, and these two conditions when x0 equals x2 equals 0, and then at the same time x3 equals 1, and when x2 equals 1 at the same time x3 equals 1. So after that we got that the probability of x3 equals 1 is 0.592. And for the third question, since it we have to find that the probability of x3 equals 1 when x1 already is 0, it is determined. So we can just simply separate also these two equations. Since x1 is always 0, we have to find the probability of x2 equals 0 when x1 is 0 and times this one, and when x2 equals 1 when x1 is 0, which is is determined at the first, and times this one, so that we got 0.52 at last for the probability of x3 equals 1 when x1 is already 0.